All right, I wanted to make a short video about practice D number 4. And in this problem, we'll go ahead and draw before and after. We have a boy riding a skateboard, holding a jug of water. And initially, we know some things about the situation, but we know that everything is at rest. So the initial velocity of all the objects is 0. So the problem kind of reads like this. It says a boy on a 2-kilogram skateboard initially at rest tosses an 8-kilogram jug of water in the forward direction. So initially he's holding the jug of water, he's on the skateboard, and the skateboard's at rest, so the boy's at rest, the jug of water's at rest. If the jug has a speed of 3 meters per second relative to the ground, that's going to be the final velocity of the water. The boy in the skateboard will move in the opposite direction, or to the left, at 0.6 meters per second, and we want to find the boy's mass. This is trickier because the boy and the skateboard are going to move together at the end, but we want just the boy's mass. Okay, and we know the skateboard's mass. So let's go ahead and label some of those. Mass of the skateboard is going to equal that 2 kilograms. Mass of the water, or H2O, is going to equal 8 kilograms. And the mass of the boy is what we don't know. All right, so that's our before situation. Our after situation, we're now going to have some movement. The boy and the skateboard will move to the left at negative 0.6 meters per second. And so we'll say that, I'll just call it VF since it's two objects moving together. I'm just going to go with the more generic velocity. I could have called it VFB plus SB, but I didn't want to. If you want to, you can. All right, and then the water is going to go flying to the right at a larger velocity. So I guess I can draw that a little larger than this. VF H2O of 3 meters per second, I believe. All right, so you have something like that. And so now we're just going to use some momentum balance to solve this problem. So I'll go ahead and write it down here. Looks like I have a lot of room. Hopefully I have enough. PI equals PF. All right, so initially we have the mass of all of these objects, the mass of the boy, plus the mass of the H2O, plus the mass of the skateboard, times this initial velocity, which is going to be 0, right? But I'll just go ahead and write it out. And then finally, I'm going to have two different objects moving, and I'm going to have to add their momentums together down here. So the first object will be 2 combined, right? The mass of the boy plus the mass of the skateboard. And that's going to be moving at that VF to the left. And we're going to add that to the mass of the H2O times the VF H2O. All right, so this is what this looks like. And so now when you see it like this, I think it becomes easier to solve, and especially once we put the numbers in. All right, mass of the boy, we still don't know, but that's going to be okay here because this initial velocity is going to be 0. Mass of the water is 8 kilograms. Mass of the skateboard is 2 kilograms. We're going to multiply all that by 0, and you can see that any number over here times 0 is going to be 0. So we're expecting when we rewrite this, that this whole side will just cancel away into 0. And so we'll end with a 0 right here. Okay, mass of the boy, we still don't know. That's what we're solving. Mass of the skateboard is 2 kilograms. Final velocity for those two objects is going to be that negative 0.6 to the left. 0, oh, got to write my negative sign though. It's super important. If you don't write that, you're going to get it wrong, obviously. Or maybe not obviously, but that's how it works. Okay, and then we're going to add that to the mass of the water, which is 8 times the final velocity of the water, which is that 3 meters per second in the positive direction. So right here, this is pretty simple to see. 8 times 3 is going to be 24 kilogram meters per second. And then right here, this is where it's trickier, right? When you have this addition sign and you're multiplying this by this, you have to factor this through, right, like that. So I'm going to end up here, and the negative sign is going to go to both. So we're going to have negative 0.6 MB plus, well, actually, it's going to be a negative times a positive, so it's going to be a minus there. 1.2. Units here are trying to stick with the uppercase K on my kilograms. Doing a decent job. Kilograms, meters per second. All right. And that's going to be added to the 24. So we can see that 24 minus 1.2, because these have the same units. You can combine these two. We can't combine this one. But 24 minus 1.2 is 23, minus the 0.2 is 22.8. So we're going to end up with a positive 22.8 kg meters per second when we combine this with this. And we still have this hanging out in front. All right, we'll kick that over to the other side. Just add 0.6 MB to both sides. Okay, so we're going to get 0.6 MB is equal to 22.8 kilograms meters per second. All right, I forget a unit here along the way. I think I did. Okay, so if I go back and look, and I'll point that out, when I multiplied this here, this negative 0.6 times this MB, it had a meters per second on it. So there should be a meters per second there. There should be a meters per second there. Oh, that's small and tough to see. There should be one there. And there should be one here and here. All right, and that's important because I'm going to divide both sides here by that 0.6 meters per second. And I want those meters per second to go away, so I'm left with kilograms, which is my unit for mass. So that's why I'm making such a big deal out of it. All right, so cancel that just like that. Cancel this just like that. And cancel your 0.6s over on the left. And you're going to end up with just MB over here. So I'll rewrite it right here. MB is equal to 22.8 divided by 0.6. Is 38. Oh, I already had it in there. Okay. 38 kilograms. I had to make this video twice because first time I had some technical difficulties and didn't record it. All right. So anyways, the mass of the boy is 38 kilograms. So that's it. Also just a little bit more algebra in this problem, but same deal as before. Momentum is conserved. Initially, there was zero momentum because nothing was moving. And so finally, there was still zero momentum, that the momentum to the left, the heavier object, the boy at 38 plus the skateboard at 2, the 40 kilogram object moving to the left at a slower velocity is equal in momentum to the lighter object, just the water moving to the right at a faster velocity. So I bet if we were to take 38, which is the mass of the boy, plus 2 for the skateboard, 40 times negative 0.6, that's equal to negative 24, and 3 times 8 for the mass here would be positive 24. So the momentum is still 0 after, so momentum is conserved, and the mass of the boy is 38 kilograms. All right, let me know if you have any questions.